n equals the number of sides. So 3 gon would be 3 sides, which is a triangle. 4 gon would be 4 sides, which is a quadrilateral. 5 gon would be 5 sides, which is a pentagon. And 6 gon would be 6 sides, which is a hexagon.
7 gon is a heptagon, 8 gon is an octagon, 9 gon is a nonagon, and 10 gon is a decagon. I'm going to show you guys how to find the sum of an interior angle. So first you're going to use the polygon interior angles theorem, and the formula for that is n minus 2 times 180. Here's an example on how to find the interior angle of a heptagon. So you're going to use the formula and you're going to plug 7 in for n because a heptagon has 7 sides. So it would be 7 minus 2 times 180. 7 minus 2 is 5. So it'd be 5 times 180, and that equals 900 degrees. So that's the interior angle. And then this is how you find one interior angle measure. First, you have to find the number of sides, and then you plug it in with this formula, which is n minus 2 times 180 over n. And here's an example on how to find 15 gon. So you're going to use that formula, and you're going to plug 15 in both ends. And it'll be 15 minus 2 times 180 over 15. 15 minus 3 is 13, so it would be 13 times 180 over 15, and that equals 156.
Okay, so I'm going to explain how to find the sum of the exterior angles of an irregular polygon. So first you're going to use the polygon exterior angles theorem, which states that the sum of exterior angles equals 360 degrees. So the example problem below says to find the sum of exterior angles of the irregular polygon below. The irregular polygon is 7 sides, but we immediately know that all of it is 360 degrees because of the polygon exterior angles theorem. Here's how you find one individual exterior angle of an irregular polygon. So first you're going to identify one interior angle measurement, then you're going to subtract 180 from the identified measurement. So the example problem below says to find one individual exterior angle of the irregular polygon. It gives us the measure 115 degrees, so we're going to subtract 180 minus 115, which equals 65 degrees. So one individual exterior angle is 65 degrees. Find the number of sides of an irregular polygon. You first identify the number of sides, then you use the formula n minus 2 times 180 over 180 equals the measurement you'll be given over 180. In the example problem, it shows us that the measurement given is 900 degrees. So we're going to use the formula n minus 2 times 180 over 180 equals 900 over 180. To simplify, you just cancel out 180 and you divide 900 divided by 180, which leaves you with n minus 2 equals 5. Once you simplify that, you get n equals 7, so it's 7 sides. For parallelogram, there are around 11 theorems, including converse and regular. Definition of a quadrilateral being a parallelogram is if both pairs of opposite sides are parallel. The example problem for parallelogram is to find x and y in parallelogram QRST. So you set up the opposite sides next to each other. This is because of the parallelogram opposite sides theorem. With that, you should get x equals 1 and y equals 3.
A rectangle is a parallelogram with 4 right angles. The theorem for it is a quadrilateral is a rectangle if and only if it has 4 right angles. One example from the book is ABCD is a rectangle if and only if angles A, B, C, and D are also right angles. Now for another example. So number 1 says the measure of angle PON equals 90 degrees, and we have 90 degrees because the theorem says that a rectangle all around has to be 90 degrees. For number 2, the measure of angle PMO is 61, and we know this because you do 90 minus 29, and that equals 61. For number 3, PL equals 12, and we know that because LN is 12. And then for 4, MO equals 24, and we just did 12 plus 12.
To start off the rhombus theorems, we have the rhombus corollary, which states a quadrilateral is a rhombus if and only if it has 4 congruent sides. 7.11 rhombus diagonals theorem states a parallelogram is a rhombus if and only if its diagonals are perpendicular. 7.12 opposite angles theorem states a parallelogram is a rhombus if and only if diagonals bisect a pair of opposite angles. The example problem states ABCD is a rhombus, find angle DEC. Angle ABC is in total 58 degrees. So angle ABE would be 28. Set up angle DEC, you do 180 minus 62 minus 28, which is 90 degrees. DEC equals 90 degrees.
A square is a parallelogram with 4 right angles and 4 congruent sides. It also has to be a rhombus and a rectangle. For one example, ABCD is a square if and only if all sides are congruent to each other and if all of them have right angles. Now for the example, number 1 says ME equals 7x minus 3 and MO equals 7x, and it's asking you to find what x is. So I did 7x minus 3 equals 6x. I minus 7 on both sides, and that gives you negative 3 equals negative x, and you can't have a negative x, so I made it x equals 3, and that's the answer to number 1. For number 2, if MT equals 4x and TE equals 3x plus 2, find OE. So I did 4x equals 3x plus 2. I minus 3 on both sides, and that gives you x equals 2. But it's asking you to find OE, so it's not done yet. So I took 3x plus 2, and I plugged 2 in for the x, so it would be 3 times 2 plus 2, and that equals 6. So I did 6 plus 2, and that equals 8. And since there's 2 sides, you do 8 plus 8, and that equals 16. So OE equals 16.
The first theorem of a trapezoid is the isosceles trapezoid base angles theorem, which states if a trapezoid is isosceles, then each pair of base angles is congruent. The second one is the isosceles trapezoid base angles converse theorem, which states if a trapezoid has a pair of congruent base angles, then it is an isosceles trapezoid. The third one is the isosceles trapezoid diagonals theorem, which states a trapezoid is isosceles if and only if its diagonals are congruent. The last one is the trapezoid midsegment theorem. You can also remember this as the midpoint. The midsegment of a trapezoid is parallel to each base, and its length is the half of the sum of the lengths of the bases. The formula for this is base 1 plus base 2 divided by 2. The example problem is asking us to find the measure of u. To find this, we just do 180 minus 59 because UR is congruent to ST, and we'd get measure of u is 121 degrees.
There are 2 theorems for a kite. One of the theorems is if a quadrilateral is a kite, then its diagonals are perpendicular, and another one is if a quadrilateral is a kite, then exactly one pair of opposite angles are congruent. Here's an example. It's asking you to find measure of angle BCD. So first I plugged in angle DAB, which equals 54 in yellow, and then I plugged in angle CDF, which equals 52. And then we know that angle CFD is 90 degrees. So I did 180 minus 90 minus 52, and we got the 52 from angle CDF, and that equals 38, and that gives you angle FCD. And so you do 38 plus 38 equals 76, and that gives you the measure of angle BCD.